Thank you for tuning in. My name is Doug Beanstalk, and I am a regional lead for incident response at Mandiant. And today I'm going to be talking about some of the themes that we've observed as threat actors have been targeting cloud environments and how that relates to the zero trust model. So before we get started, I want to ground our discussion in this slide, that when we think about access to the cloud, and that could be Google Workspace, that could be Azure, that could be Amazon, Slack, anything in the cloud, we need to remember that the foundation of all security is going to be identity and token management. We're not dealing with a traditional on-premises environment where there's a network perimeter with firewalls and end user devices and servers that we need to keep track of. This is the cloud, where really the only thing that matters at the end of the day is the identity and the token that's going to encapsulate that identity. So it's a very different way of thinking about things. We're going to start by talking about tokens. What are they? Why do threat actors want to target them, and how? We'll move into speaking a little bit about how tokens may be used for persistent access to an environment. And then lastly, we'll talk about hybrid clouds, which is where a lot of traditional organizations find themselves and some of those challenges that come with it. So in our cloud model, we're going to have a lot of different users that need to access data. That could be regular everyday users, administrators with higher levels of privilege, or even service accounts or automation accounts that need to conduct actions without a user being present. And that access is going to happen from a number of different places. We have computers or servers that are owned and managed by the organization. Increasingly, more employees are able to access some elements of the company's cloud through their own machines, through BYOD. Access may even occur from a hotel lobby, business center, for example, or also from virtual machines that they themselves are in the cloud. And all of this access is going to be governed using tokens. So that key in the middle, those are our tokens. These traditionally are JSON web tokens, but they could also be cookies. They could also be SAML tokens, or really anything that I can exchange between my computer and a cloud resource to prove that I am who I am and gain access to resources. And those resources could be varied, right? We could be talking about cloud-based email. We could be talking about chat applications, SaaS, or compute instances. But it's always going to be a token that we exchange at the end of the day. So why are threat actors going after tokens? Well, really, they're one step better than just having a username and password. As I've already started talking about, these tokens are identity as code. They encapsulate someone's identity and thus what they're able to access in the cloud. Typically, once you have a token, you no longer need a password or MFA to access those cloud resources. And oftentimes tokens are going to be found on disk on these machines, right? These applications, whether it's a web browser or a thick client application, it needs to store those tokens somewhere, because every time a user tries to access a cloud resource, they don't need to present their username and password every time. That's because these tokens are stored on disk and they have some amount of validity, right? They can be valid for hours or sometimes even months at a time. And often these tokens only become invalid when a user changes their password, or sometimes not even in those cases. So all of this is to say that threat actors are very interested in tokens because it allows them to access data that on a user's behalf without needing that user's password, without needing MFA, and potentially being able to access those resources from anywhere in the world. So let's talk a little bit about how threat actors have been stealing tokens. One common path we see is through a class of malware that's commonly called infostealer malware. This malware really has one main job, and that's to scour a machine to look for saved credentials. Now, this could be standard username and password credentials that are stored in your web browser, but it could also be session tokens, cookies, and even cryptocurrency wallets, which is a little bit different, but sometimes these financial crime actors, they like to kill two birds with one stone. Now, this is a little bit of a departure from traditional intrusion vectors because this malware is often operated by financial crime groups. They're just motivated by money. And how this typically works is the malware is distributed via software cracks that are Trojanized. The malware will phone home those credentials, and then the threat actor will package them up into tranches and sell them on the dark web. Sometimes you can even search the dark web for specific companies or domains that you are interested in credentials for. And this is really interesting because we've observed over the years a number of threat actors, including APT29, but also some more financially motivated extortion groups, searching the dark web for credentials for particular types of applications, purchasing those credentials, and then using them to access victim organizations. And keep in mind that sometimes these tokens, especially if they are refresh tokens, do not require a password, do not require MFA to access that cloud resource the token is valid for. Then when we go to our privileged users, oftentimes these administrators, they need to perform automated tasks, and they need to do them often. These administrators, they're not going to do this through the UI. Think about bulk user assignments, preparing reports, setting different policies. Oftentimes this is going to be done over an API. And to access that API, these admins need tokens. Oftentimes this is going to be in the form of an OAuth bearer token. It could also be a more traditional API key. But oftentimes you're going to find these tokens saved to disk in an unencrypted format, and they may even be on a file share because you have a team of admins who need access to this token in order to do their job. And so we have observed a number of threat actors that actively search machines for these types of privileged tokens, specifically looking for IT admin workstations and then searching for those tokens. We worked an intrusion where APT41 found one of these privileged OAuth bearer tokens and used it to harvest email from a cloud environment. We also see cases where threat actors look for specific desktop applications that access the cloud and the tokens that those desktop applications need to perform that access. So oftentimes these tokens are going to be saved to well-known locations. In Windows, this is often the app data folder. And we've observed threat actors targeting those app data folders for collection and then later authenticating to those cloud platforms using tokens that were stored by the thick client applications in those folders. The last thing I want to talk about with token storage is third-party token storage. And this can fall into one of two different buckets. The first is the more traditional MSP model, where organizations give access to their MSPs in order to allow them to do their jobs. Now, a lot of the times this takes the shape of usernames and passwords, but there can also be cases where those MSPs, just like the internal IT admins, they need to perform actions in an automated fashion against an API. And so tokens are created and given to those MSPs or to those third parties. And Mandiant has observed cases where threat actors compromise those MSPs and go after file shares or the MSP desktops themselves, where tokens for a number of third parties are stored, and then the threat actor uses those tokens to move downstream. Now, similarly, in a cloud environment, there's usually a rich plugin or a marketplace environment for you to extend the functionality of that cloud by connecting third-party applications to your data. This is often called an OAuth consent grant. Now, in order to facilitate that, the third party is going to receive some sort of token that they can then use to access data on your behalf. And Mandiant has observed cases where threat actors have compromised those third parties, specifically looking for the production systems or databases that are storing those tokens they receive after customers consent, and then using those tokens to access those downstream victims and the data stored in their clouds. Now let's talk a little bit about the hybrid cloud. As I mentioned, a lot of organizations find themselves in this hybrid model, where there's still a traditional or legacy on-premise environment that likely predates the cloud, but there's also a cloud environment, and we need to link those two together. And importantly, organizations don't want their users to need to remember two different sets of credentials, one for the on-premise network and one for the cloud network. And increasingly, the line between on-premises and cloud is getting blurred, so much so that most people might not even know it exists. But in order to make that linkage transparent, you need to have a set of systems that can actually facilitate identities being able to move from one to the other. And those are what this diagram calls out as identity sync systems. Now, as you can see in the middle, again, tokens are going to come into play to link these two different environments together. And if a threat actor is able to compromise an identity sync system, they're oftentimes able to compromise both the on-premise environment and the cloud. And so we've seen APT29 and a number of other threat actors, such as APT41, financially motivated threat actors, even some ransomware actors, target these servers running applications such as Azure AD Connect, Okta Sync, because they have very sensitive credentialing information that can be used to create your own tokens to access cloud environments as any user in the environment. A subset of that technique is something called golden SAML. So I've talked a lot about OAuth bearer tokens. There's another type of token that's really important to remember when thinking about the cloud and a federated trust model, and that's called SAML, or Security Assertion Markup Language, which is basically just another text document, this time it's XML, that represents someone's identity. Now, in order for the cloud resources that receive those SAML tokens to know that that SAML token is actually valid and can be trusted, we're going to need to rely on cryptography, specifically a cryptographic key. And so those identity sync systems are going to contain that cryptographic key so that they can create a SAML token and allow a user to access that cloud resource. And so when we say that these identity syncing systems are the bedrock of security for the cloud, what we really mean is that the cryptographic key that these identity sync systems store is the bedrock of security for the cloud. And so if a threat actor is able to steal that key, they can create tokens and become any user in the environment, potentially not needing to know that user's password or even needing to possess MFA for that user. And so we've seen a number of threat actors over the years make use of this technique in order to access the cloud. So what have we learned from all of this? Well, first, we've learned that the idea of tier zero, it needs to be constantly expanding. So tier zero systems are traditionally thought of as domain controllers, maybe systems that control crown jewels, but we need to include that or expand that to include our identity sync systems so that we treat them just as equally as our domain controllers and as our other crown jewel systems. We also need to expand our risk model and our threat profile to include commodity malware. Most infostealer malware is easily caught by enterprise-level EDR tools. But because we have BYOD policies now, and because these commodity malware infostealers often infect BYOD systems, we need to include that in our threat model. We also need to think more carefully about BYOD and what it means for access to our cloud. Restricting it as much as possible is the best practice. And at Mandiant, we've seen a little bit of a backtrack on just what resources users can access when they're not on a company device. This next one I think is really critical, and it's not something that oftentimes organizations think about, and that's secure token lifecycle management. So making sure that we understand how tokens are issued, how long they're valid for, where tokens are going to be stored by our administrators and by our automation systems, and how to securely get rid of or remove or recycle those tokens. And just as importantly, the concept of zero trust needs to expand to tokens and to the automation accounts that these tokens might be using. Being able to strictly scope a token to only the roles and privileges that the particular use case requires is going to be incredibly important to limit the impact of any breach or any tokens that may or may not get stolen. So lastly, how does this all relate to zero trust? There's a few things that we want to do here to make sure that we can effectively manage our tokens. And even when we deploy a zero trust model, tokens are often going to be very important to that zero trust model, right? We're still going over the cloud. We're still accessing a diverse set of resources. But there's a lot of steps we can take to make it much more difficult for a threat actor to take advantage of tokens. The first is going to be a strong verification of the user. And what this means is moving away from the traditional model of a username and a password to and using more secure options like YubiKeys and passkeys. This also means forbidding the MFA methods that are now very easily taken advantage of, such as SMS messages, voice calls, or blind push. We also need to think carefully about the devices that our users and our automation accounts are accessing the cloud from. We want to ensure that we can have near real-time telemetry about all of our devices. This would include things like the patch level, the security stack installed. Is the security stack actually healthy and phoning home? And are there any third-party applications installed on this endpoint that we don't like or that policy prohibits? And we want to actually take action against these devices. More on that in a little bit. Being able to identify a device is equally as important as being able to make sure a device is healthy. And what I mean by this is if an authentication occurs from an IP address and from a particular user agent, I want to be able to actually say, this device is a device I own and a device I trust. And the best way of doing that is with device-based authentication or unexportable certificates, using technology such as TPMs, which are included on most systems that are manufactured in the last few years, to make sure that I can actually tell that a user is using the device they're supposed to be using and that I trust this device. And lastly, we want to make sure that we're evaluating the context of an authentication at all times. And this is going to include things like the client network location. So is my user moving locations as they're accessing the cloud? What is my user's role, and should they be attempting to access this particular cloud-based resource? And what types of commands or what types of devices or times of day is my user accessing the cloud from? And it's very important that as we're evaluating all of these different conditions, that we take action. Now, a simple action would be to simply block access when something happens that is unfamiliar to us. That could be a user accessing from a device that we can't verify the trust of, or from a location that seems anomalous. But with zero trust, we can take more nuanced steps. If something changes that is suspicious, such as a location, perhaps a token has been stolen because first it's seen on a corporate device, and now that same token is seen somewhere else, we may ask the user to prove that they still are who they say they are. And when we go back to thinking through strong identity verification, we know that if we ask a user to prove their identity again, and they do it successfully, that that user is who they say they are, because this proof or this reproof is done using something like a passkey, something that is very difficult, if not almost impossible, to be stolen. As we take all of this together and think more about zero trust, you can see how it's very easy to start mitigating some of these common attack paths for token theft and ensure that access to our cloud is done securely and only from resources that we trust. And with that, I thank you for your time and enjoy the rest of the conference.